Hello, I'm Greg Crinklaw, the developer of SkyTools. Have you ever taken images of M42 and wondered how many others are doing the exact same thing right then? The sky is full of interesting target objects, but many imagers end up imaging the same ones as everyone else. Fortunately, SkyTools has an extensive database, and it can determine whether or not an object is suitable for your imaging system. In this tutorial, you are going to learn how to find your own hidden gems. The database power search is open from the target selection tool. It is located here because it is part of the target selection process. Click the Add Objects menu and select Database Power Search. It might at first appear a little daunting, but I think you will quickly master it. This area here is where you define the basic search parameters, such as the type of objects and things like how bright they are, how far away, and other kinds of catalog data. The search is broken down into tabs depending on the object class. Search for stars in this tab, deep sky objects within our galaxy, objects beyond our galaxy, minor planets, and comets. These are grouped together based on the types of data that can be searched. Over on the right are general search parameters, which apply to all classes of objects, such as searching a specific constellation. These work in conjunction with the search parameters on the left. This column allows you to apply filters based on how suitable the object is for the specified imaging system. This, too, works in conjunction with the other search parameters. Let's start with stars. Now, I know many of you are not interested in searching for stars, but many of the same basic ideas apply to all types of objects, so bear with me. By checking one of these boxes, you can limit the search to multiple star systems or variable stars only. If both boxes are checked, the search will be limited to multiple star systems that have one or more variable component stars. The supplemental star database primarily contains novae and supernovae, which are added to your supplemental star database when the current novae/supernovae lists are downloaded. If none of these boxes is checked, the entire star database is searched. In this area, you can search for objects that have a designation for a specific catalog. Click Select to enable it. These are all of the different kinds of catalog designations. If I select Common Name, or Bear, or Flamsteed, or maybe all three, then I am only going to search for bright naked eye stars, because for the most part, only the bright stars have these designations. Let's search for variable stars with common names. The results appear in the table at the bottom. There are 107 of them. You can sort them alphabetically by constellation, magnitude, etc. Double-click to see the full object info. The columns over here only apply if you have enabled the imaging system or specific date filters. We will look at those later. Looking for one specific object, you can double-click to open the object information to investigate its suitability for your imaging system. And if you decide to image it, you can go ahead and create an imaging project for it. The other thing you can do is to create a target list for use in the target selection tool. Click on the objects you want to include in the list. You can select a range by selecting one, and then while holding down the Shift key, select another. Click Select All to select all of the results. Select an existing target list to add these objects to, or create a new one. I'll create a new one called Test, and I'll put it in the default folder. Click OK. The new target list is automatically selected. When I click Add to List, all of the selected objects will be added to the Test target list. Now, I could open it in the Target Selection tool to determine which of these is suitable for my imaging system. So these are the main filters. These variable star filters become available when you have the variable stars only box checked. Let's narrow it down to pulsating variable stars only. This gets us 43 stars. These are all of the pulsating variable stars with common names. You can further narrow down by specific type of pulsating star. Here are all the beta Cepheid variables. Beta Cepheids are periodic variables, and here are their periods. This is how long it takes them to go through a complete cycle of variation from bright to faint and back to bright again. For periodic variables, you can assign a range of periods. Let's show only those with periods longer than 6 hours. This is a greater than or equal sign. Only stars with period equal to or greater than the period I enter here will be listed. The period is specified in days, so I will enter 0.25 days. Click and select Enter Value. Then type the value and press the Enter key. So it turns out that there are two pulsating Cepheid variable stars with common names and periods greater than or equal to 0.25 days, or 6 hours. You could similarly set an upper limit to the period. To clear a search value, click and select None. Searching for double stars works similarly. SkyTools brings together all of the component stars into a single star system. So if there is an AB pair and an AC pair, or even a BD pair, they are all part of a single system tied to the primary star, A. So the search results may apply to any pair in the system. If pair BD meets the search criteria, then the whole system is returned as a match to the search. You can enter a range of allowed separations in arcseconds, or limit the results to systems that include pairs of stars that differ by no more than the magnitude specified here. If you check this box, the search will only return multiple star systems with pairs that have known orbits, and you can limit the orbital periods. For example, you could return long-period binary stars with orbital periods of 100 years or less. Here is the BC pair of Almach, for instance. I remember when you could easily see this pair in a small telescope, but now they're too close, separated by only 0.25 arcseconds. If I select the BC pair, you can see its current separation and position angle. Filter by magnitude here. Note that the greater than or equal sign is mathematical. It doesn't matter that star magnitudes go backward. So if you want to set a faint limit, say limit to stars brighter than 6th magnitude, then set the one on the right. So this says to list stars that are less than or equal to magnitude 6. These filters limit the color, expressed as a B minus V magnitude. So how do I know that I'm supposed to enter a B minus V magnitude here? That's when you need to click the Help button. Click on Star Search, Reference Database Limits, and it explains that you need to enter B minus V magnitudes. If you don't know what that is, don't worry. Some things are here only if you need them. They can be ignored otherwise. You could limit the search to only stars closer than, say, 10 light years here, to stars with large proper motions, minimum radial velocity in kilometers per second, and in some cases, you may only want stars from catalogs that have accurate coordinates. Remember, you do need to click the Search button to make a new search after changing the filters. I'm going to click the Reset button to reset everything back to the starting point. I will enable stars with Bayer designations only. That's stars with Greek letters, such as Alpha or Beta. I will enable the constellation search over on the right and select Andromeda. Here are all the Bayer or Greek letter stars in Andromeda. I can search more than one constellation too. I can select them all, maybe because I wanted to exclude only a few constellations. Or I can clear the list. I'll disable the constellation filter again by selecting any. Sometimes you might want to search around a position in the sky. To do that, enable the Search Radius filter. Type in a search radius and select the units. Let's search a circle with a radius of 10 degrees. Click on Nothing to select the position in the sky to search around. I can enter an object to search around. Let's enter M31. And now it will return only those objects that meet the criteria on the left that are within 10 degrees of M31. So here are the Bayer stars within that search radius. The separation column tells us how far away each star is from M31. You can also specify a position in the sky by selecting the Enter Coordinates tab. I'll enter 12 hours and 10 minutes for the RA, and 33 degrees 4 minutes for the declination. I'll press Accept. You can check that you entered it correctly here, and press the Accept button at the bottom to close the window. There are only 2 Bayer stars within 10 degrees of our coordinates. Lastly, you can select objects based on whether or not they already have an imaging project associated with them. If I select No Project, then only those targets that don't already have an imaging project created for them will be listed. Or I can reverse that. Okay, enough about stars. I'll select Galactic Deep Sky Objects. Select one or more types of objects to search for. I'll select Planetary Nebulae. The catalog designations work the same way as for stars. I'll enable it. And I'll select the Abell catalog designation. Clicking Search, here are all the Abell catalog planetaries. Some of these may have other designations, like this IC planetary. But if I open the object info, we can see that it is also Abell 81. You can limit the search to a range of magnitudes, sizes, and distances. So these filters here apply to all of the databases. So here are all the Abell planetaries within 1,000 light years. Some search parameters apply only to certain types of objects. Here are the planetary nebula search parameters. I'll clear the distance. I can select a minimum surface brightness in magnitudes per square arcseconds. Some common values are listed. I'll select 24, which will only show those with a surface brightness higher, that is a smaller number, than 24 magnitudes per square arcsecond. You can also search on morphology. Here are all the ones with a ring structure. I'll add diffuse nebulae to the search. Diffuse nebulae is a catch-all term for H2 regions, reflection nebulae, and supernova remnants. I'm turning off the designation filter, and I'll set it to show supernova remnants only. So here are all the planetary nebulae with the ring structure, and supernova remnants with a surface brightness of 24 magnitudes per arcsecond squared or brighter. Down here are the supernova remnants. Dark nebulae can be filtered by type and opacity. Higher opacity values block more starlight, and so they usually show up better. Here are the ones with the highest opacity, 6. Open clusters can be filtered by age, and of course, these filters over here apply as they did with stars. Okay, on to Extragalactic. By the way, don't be put off by the fact that you have to search galaxies separately from, say, planetaries. Once you have a list for one, you can change the search and append new search results to the same target list. As before, select the subtype of object. Here are all the Hickson galaxy groups. As before, you can filter by a range of magnitudes and sizes. For extragalactic objects, filtering on distance works differently. You have the choice of searching via redshift, also known as Z, or by light travel time. Here are all the Hickson galaxy groups with light travel times greater than 1 million years. I'll clear the search and select quasars. Let's find the really distant ones with look-back times close to the age of the universe. I'll enter 12 giga or billion years. I'll sort by magnitude. Here are some you could maybe image. These are limits that apply only to galaxies. You could also choose to include BLAC objects in the quasar database if you want to, or you could exclude them. And you could search for galaxy groups with a minimum number of members. Minor planets and comets will be covered in separate advanced tutorials. So finally, let's look at the imaging system date filters. I'm resetting again. I'll make a list of galaxies that are barred spirals that were originally observed by William Herschel. These were discovered visually, so they're going to be nice and bright. Here they are, 290 of them. Now I'll select an imaging system, in this case the default system. When I did that, the size filters became available. I can specify that it has to fit into a single field of view, so no tiling, and it will show only those with an excellent image scale. This will filter out the ones that are too big or too small. I'll place it at Mesa Redonda Observatory. So here's a list of barred spiral galaxies discovered by Herschel with an excellent image scale in this imaging system. Note that these other columns now have data in them, such as the size on the image in pixels, how long the object is high enough to be imaged, and the best date of the year. This is the number of days over which it is well observed during the year. You can add a filter for a time of year. Here are the ones available in the winter. You could go ahead and make a target list for these objects, or you could further narrow it down for your imaging system. Let's select a specific night. I'll pick November 13th. So now these exposure filters are available. You can choose the SNR that you want to achieve. I'll pick higher picture quality, or 30. I'll also set the maximum exposure time allowed to reach the target SNR, in this case 30 minutes. So these are all of the barred spiral galaxies discovered by William Herschel that our imaging system can attain an SNR of 34 in 30 minutes or less on the night of November 13th, 2020. If you think about this, you might ask, hey, Greg, which filter is this result for? What binning? What focal changer? When it makes this calculation, it selects the best possible case, which will usually mean the widest filter, such as your luminance. It will select the focal changer that works best, and it will try to use 1 times binning, but will use higher binning if necessary to obtain a reasonable SNR. So it's basically the optimum case. Your blue filter, for instance, will probably take longer to reach the same SNR. If you are interested in searches related to comets and minor planets, please see the advanced tutorials for these topics. So that's it. Clear skies, and thanks for watching.